So today in Mat120 Intermediate Algebra, we're going to talk about 4.7 rewriting formulas. Okay, and I wrote down a couple of things that you want to consider when you're doing this. Number one, what letter are you trying to solve for? A lot of times students solve these things and they're solving, they ask them for the width and they're solving for the height or something like that. So you want to know what letter, is it a W, is it a capital R, what is it? The next thing you want to do is once you have your formula, is you want to eliminate any fractions using the magic number. And number three, sometimes you have parentheses, you want to distribute them or take those into consideration. Finally, you're going to isolate the letter that you're trying to solve for, get all the terms together, make sure you get all the like terms together and the letters together, and then kind of simplify it. So that's kind of the idea behind it. We're kind of go through these as we're solving some. Some students really find this easy and some students find it very, very difficult. Let's try a very, very simple problem. And you don't even have to know what these stand for, these letters. This is something that to do with the focal distance, focal length, and things like this. First of all, you have to know what letter you're solving for. So we want to solve this for D. Notice that D is in the denominator. So let's put this over 1. We're going to use our magic number. We're going to multiply both sides by D. This will give us DF equals DL, right? But the D's here are canceled, so it should be just L. Okay, wake up. All right. So we're solving for, we're solving for the letter D. Okay, I'm all messed up here. So anyhow, that's what we want to do. So now what we're solving for is this D. So we have to, this is a times, so to undo the times, we have to divide both sides by F. So D would equal cap L divided by F. And that's it, that's basically the idea behind it. So we're going to still use the magic number if we have to, if they're fractions or whatever. All right, let's try one that's a little bit more interesting. Here we have, what are we going to solve for this one for? We're going to solve for cap D. Solve for capital D. And our equation is L equals small dr, capital R, capital D minus small d. Kind of weird. Okay, so we know what letter we're solving for. It's D. It's in the denominator. We want to get rid of this D minus D fraction, so we're going to use that, put this over 1, D minus D, D minus D. Maybe you can put it in the parentheses if you want. So here we got L times cap D minus D equals dr times D minus D, but that's going to cancel out, so it's just times dr. That was the whole idea of doing this, so those cancel off. Okay, now we're solving for capital D, but D is locked up inside this parentheses. So the first thing we're going to do is distribute LD minus LD equals dr. Let's get this LD by itself. The D, try to get D as much as you can isolated. So let's get rid of the L minus LD thing. So LD or DL, you can write it either way, is equal to, let's move this to the other side, plus, since the D comes first, we'll put the little D here first, DL. You could factor that, but it's really not necessary. Okay, now finally, I want to get D by itself. So this is times, I want to divide off the L. So cap D is equal to dr plus dl over L. Now, don't make this mistake of canceling those. Remember, the only way you can cancel is to factor and then cancel. If we factored, we just take out a D and that would help us. So the L's cannot cancel. So most of the time, you're going to get into a situation where you cannot cancel. So that's what you want to do. Now, we're going to take the same problem, basically, and now we're going to solve for small d, little d. So let's write this problem again. So we're going to start out the same way with a magic number, d minus d, d minus d. Here nothing cancels. The object is we're using a magic number, so these do cancel. dr. So just like the other problem, this d is locked inside this parentheses. So we're kind of stuck with it inside there. So we're going to distribute. It could be dl or ld minus, this could be ld or dl. Just put dl equals dr. Okay, but we have two dl's, two small d's. So we don't want one on one side, one on the other. You know you're doing it wrong if that happens. We need to bring this over to the other side. We need to add a dl to both sides. Add a dl here, add a dl here, small d. Capital DL equals d times r plus d times l. Now let's get this down to 1d. How can we do that? Let's factor that out. Just some basics, basic factoring, r plus l. So d, small d is being multiplied times this whole thing. So now to get d by itself, we have to divide off this whole parentheses. And again, we don't want to cancel the l's. So we can see these cancel off, and d, a lot of times the variable might be on the right-hand side. That's okay. R plus L. And there's our answer. So that's what small d does. So you can see there's quite a bit of difference between these two answers. You're solving for big D, you're solving for small d. When you have multiple d's, multiple variables that you're solving for, get them on the same side. Then use factoring. That's the key. It could be something just like our basic or common factoring, but you want to get it isolated. Then you can divide off that. Here's one with resistance on a circuit. If you were into electronics, 1 over the total resistance is equal to the sum of all the little resistances. And you can figure out how many ohms or something. Okay, so we want to first of all get rid of the fractions. But first we want to know what are we solving for? And we're solving for r sub 1. That's how this is pronounced. R sub 1, R sub 2. Sometimes people say R1, R2, and that's okay too. So we want to use the magic number. And what is the magic number? The magic number is multiplying all these together. R, R1, R2, R, R1, R2, R, R1, R2, D2. No, R2. Sorry. So the R's cancel. Get R1, R2 equals R1s cancel, cap R, R2. The R2s cancel, R, R1. What are we solving for? R1. They're on either side of the equation. We need to get them together. We need to get this R1 over to the other side so it can be with its buddy. We could move them the other way, but then we do double movement. So let's move this one over. We got R1, R2. Look at new buddies coming over, R1. Easy to get confused. Okay, we're moving this over here. And it became minus because we changed sides, changed signs. And on this, it's all by itself, R2. Now, R1 and R1 are here, but how do we get them together? Factor, common factor, common factoring. So we're going to pull out that R1. We have an R2. We're going to pull it out of here. We got a cap R equals R times R2. Finally, we want to get this out of there. We want R1 by itself. So we're going to divide both sides by R2 minus R. R2 minus R. And don't try to cancel anything. You know, the only way you can cancel is to factor, and these don't factor out very nice. So these do cancel off because they're exactly the same. But here, nothing cancels. R, R2, R2 minus R. And that's our answer. So they're not too bad. We'll try one more and see if we can solve it. Here's an interesting one. We got E over little e, this is number 18, equals R over R. And what do we want to solve this for? Little e. So again, magic number, ER. Put that in parentheses. E's cancel out E's, ER equals R's cancel out cars. We got E times R plus R. Now, we're solving this for E. Might be tempted to distribute because we see a parentheses, it's kind of automatic, but this times this. So we just want to get rid of this R plus R thingy. So we're going to divide that off. We don't want to redistribute. We're going to divide both sides. It's kind of a tricky problem because we usually want to distribute. So this is our final answer. ER, R plus R equals E. See? Okay. Hope you enjoyed it. Practice. Do a bunch of these. See how good you can get at them.